today, let us look at areas of similar triangles. Let us take two similar triangles ABC and PQR. Now, in order to find the areas of these triangles, let us drop the perpendiculars. AM for triangle ABC and PN for the triangle PQR. Now, we know that area of a triangle is half times base times height. So, let us look at the ratio of areas of these two triangles. Let us substitute the values of base and height. So, for triangle ABC, we get the area as half times BC times AM. And for the triangle PQR, we get the area as half times QR times PN. Upon simplifying, we say that the ratio is BC times AM divided by QR times PN. Let us see if we can simplify this further. Let us look at the triangles ABM and triangle PQN. Now we know that angle B is equal to angle Q, since the bigger triangles ABC and PQR are similar to each other. So all the corresponding angles would be equal. We also see that angle M would be equal to angle N, since both of these are right angles. So by AA similarity, we can say the triangle ABM is similar to triangle PQN. Now we know that the corresponding sides of two similar triangles are in proportion. So we can say that AB by PQ would be equal to AM by PN would be equal to BM by QN. Now look at the ratio of the areas of the two triangles. We have AM by PN. And we have just seen that it is equal to AB by PQ. Let us look at BC by QR now. Since the two bigger triangles are similar, we can say that the corresponding sides of the bigger triangles would also be in proportion. So AB by PQ would be equal to BC by QR. Now let us substitute the values of BC by QR and AM by PN. And we get the ratio of the areas of the two triangles as AB square is to PQ square. Now since the ratio is equal to AB square is to PQ square, we can extend the logic and see that it would be equal to BC square by QR square as well as AC square by PR square. So for two similar triangles, the ratio of areas of the triangles is equal to the square of ratio of its corresponding sides. Let us look at a few problems. ABC and BDE are two equilateral triangles such that D is the midpoint of BC. Ratio of the areas of triangles ABC and BDE is. So let us draw an equilateral triangle ABC. Since it is equilateral, all the angles would be equal. Now we are given D is the midpoint of BC and we have to draw a triangle BDE. Triangle BDE is also equilateral, so all its angles would be equal. But we do not have any altitudes here, nor we know whether the two triangles are similar. So let us see if the two triangles are similar. So let us look at triangle ABC and triangle EBD. We see that angle B is common to both the triangles. And we also see that since both the triangles are equilateral, angle A would be equal to angle E. All the angles would measure 60 degrees. Similarly, angle C would be equal to angle D. So the two triangles are similar by AAA similarity. Hence, the ratio of areas of these two triangles would be equal to the square of ratio of corresponding sides. So let us take BC square by BD square. Why are we taking these two sides? Because we are given that D is the midpoint of BC. So we could write BD as half of BC or BC as twice of BD. So we get 2 times BD whole square divided by BD square. Upon simplifying, we see that the ratio of area of triangle ABC is to area of triangle EBD is 4:1. Let us look at another problem. In the given figure, ABC and DBC are two triangles on the same base BC. If AD intersects BC at O, show that area of ABC divided by area of DBC is equal to AO by DO. So we are given these two triangles and we do not have any other property to follow. We just know that they are on the same base BC. The only property visible is a pair of vertically opposite angles. But the angles are not common to the two triangles we have to find the areas of. So let us recall our tricks. We could join diagonals, but the diagonals are already joined. Or we could draw perpendiculars. Well, we have to look at the areas of the two triangles, so we would anyway need the altitude. Let us try dropping a perpendicular then. So let us drop AE perpendicular to BC and DF perpendicular to BC. Now, let us write area of ABC divided by area of DBC. So applying half times base times height, we see that area of triangle ABC is half times BC times AE. And area of triangle DBC is half times BC times DF. Upon simplifying, this is equal to AE by DF. Let us call this statement 1. Now let us look at the two triangles that AE and DF are a part of. So we are looking at triangle AEO and triangle DFO. Do you see something? Angle E is equal to angle F since they are right angles. And we have already spotted a pair of vertically opposite angles. Angle AOE is equal to angle DOF. So the two triangles are similar due to the AA similarity. And now the corresponding sides would be in proportion. So AE by DF would be equal to AO by DO. Now let us call this statement 2. We see that AE by DF was also there in statement 1. So from statements 1 and 2, we see that area of triangle ABC is to area of triangle DBC is equal to AO is to DO. Let us look at another problem. DE and F are respectively the midpoints of sides AB, BC and CA of triangle ABC. Find the ratio of the areas of triangle DEF and triangle ABC. So we have a triangle ABC and we are given the midpoints of these sides as D, E and F. Let us join D, E and F to form a triangle. Now we have to find the ratio of the blue triangle and the green triangle. Now all we have are midpoints. So let us recall the midpoint theorem. If a line is drawn parallel from the midpoint of one side, then it bisects the other side. Also, we know that such a line segment is half the length of the parallel side. So DF would be half of BC. DE would be half of AC. And EF would be half of AB. So we have the ratios DF by BC, DE by AC and EF by AB all are equal to 1 by 2. Now instead of BC, let us write CB and instead of AC, let us write CA. Now they are corresponding sides of triangles ABC and DEF. So by side proportionality, we see that triangle ABC is similar to triangle EFD. Now since the two triangles are similar, the ratio of their areas would be equal to square of their corresponding sides. So let us write area of ABC by area of DEF as AB square by EF square. Now we know that AB by EF is 2 by 1. Substituting, we get 4 by 1. So the ratio of area of triangle ABC is to area of triangle DEF is 4:1.